Yeah.
All right, well, very good. So it's my pleasure to introduce our speaker this evening, Ron Payne. When the local military industry, satellite industry needs cables wired, Ron is the guy that they turn to. So we have a true expert this evening speaking to us on this subject. The title of Ron's presentation this evening is The Timorous Art of Termination. So over to Ron.
All right. Thanks, guys. Am I coming through? Okay. Very good. All right. So now there's the one I made for you, Ray. That's the one I made for you. So I gave this briefing about 2 years ago. However, we did actual construction and actual installation. We're not going to do that tonight. We have so many new members that I wanted to go over what these connectors look like that we use in ham radio and what coax that we use in ham radio. So I've got examples I'll be passing around and kind of the history of the connectors, history of the cable. I think you guys will enjoy this tonight. We're also going to go over some tape that I use for keeping the water out. So let's start with this. Coax, as of 1938, is our most popular transmission line. I know a lot of hams do use twin lead, but coax is still the most popular. The purpose is to connect a transmitter receiver with minimum amount of loss. That's our idea, guys. You might wonder what coax stands for. It stands for concentric axis. We have a shield that prevents the pickup of external energy. Good thing about coax, you can put it right up against a metal wall, unlike twin lead. It was invented in 1929. At least they have the patent. The actual coax was from 1898 for the transatlantic submarine cable. But in 1929, Lloyd Espenscheid and Herman Affel of AT&T were working on television, and they came up with the patent for coax cable. The first commercial coax that you could buy was 46, and it was called RG8. So I know a lot of you wonder what RG stands for. Radio Guide, and this was the 8th of a series. You'll always see a /U after your coax, and that means universal or utility, but universal is the one we use most, meaning if I go to Japan, I can buy RG8. I can go to Germany and buy RG8. It's pretty standard. Pretty good brands here. You guys go out and you spend $3, $4, $5, $10,000 on a radio. Don't skimp on the coax. Belden, Times Microwave, and Wireman, these are all top of the line. All I buy is Belden. I'm a Belden guy like I'm an ICOM guy. Okay? But Belden is really good. For those of you who've never seen cable inside, maybe you're just starting in radio, we have a jacket. The jacket can be PVC, polyethylene, or polytectafluoroethylene, which is Teflon. Teflon, you betcha. Boy, that's nice stuff too. That's we use that for maritime and MilSpec type stuff. The only jacket that I like, that I buy, is Class 2A PVC jacket, non-contaminating. Anybody know what that means? That means that's right. The jacket does not cause a chemical reaction with the braid, okay, and turn the braid yellow or green or whatever. Petroleum resistant. You can lay it right in a tar roof if you want. Done that before too. Direct berry. UV resistant with a 10 to 15 year lifespan. Well, I try to replace mine a little more often, but that's what they claim. The outer conductor can be braided, solid, single, or double. The dielectric, polyethylene foam, polyethylene solid, or Teflon, or even air. And the inner conductor can be solid or stranded. 7 strands for most of the cable I have on the table here, and I do have some solid also. So that's pretty much a cross section of coaxial cable. Keep in mind, guys, that the RF travels on the outside of the inner and the inside of the outer. So it's like a waveguide. It's a flexible waveguide. That's exactly what coax is. There, it's traveling. There we are. I knew that worked. Okay. Now, George Lee Master brought over to my house a LC measuring device, which is the coolest thing I've seen. And we hooked it up just to a piece of cable. And we measured the L, inductance. We measured the C, the capacitance. And it came out to 52.4 ohms or something. It was absolutely perfect. So everything's based on this formula. Please keep in mind, guys, that coax cable is an electronic circuit. It's a circuit. You got resistance between the center conductor and the shield. You have capacitance between the center and the shield. It's a dielectric separated by 2 metals. You have resistance of the copper or the aluminum or the stainless steel. And of course, your braid is just one big long coil. So that's basically what you have right there. Now, MilSpec 17C, I don't even know why I'm bringing this up, but MilSpec 17C was replaced in 2005 by MilDTL 17H. And the only reason I'm bringing this up, none of us in this room are going to go pay numerous dollars a foot for MilSpec cable. But let's just say you're at a ham fest and you see a roll of MilC 1774. You don't know what it is, and the guy wants a good price for it. Look it up on your phone. It's RG213. Yeah, I'll take that. So this is a MilSpec version. So for any questions on this, just go to MilDTL 17H. It's fairly new. And just remember that the RG stuff that we buy at Hamfest, or I buy all my stuff at the RF Connection in Gaithersburg, I use good old RG cable. That's good enough for us ham operators. All cable has loss. Sorry about that. Due to dielectric and the conductor resistance. It does have loss. Please keep in mind, this is the most important for hams. As we go up in frequency, attenuation goes up too. You're not going to use RG174, 100 feet of that for 2 meters. That's just not a good idea. It decreases as the thickness and quality. Quality, got that? Quality increases. Okay. Power handling, cable size, and Bob was so good to give me a piece of this. This is 1 1/4 hardline. Thank you, Bob. This reminds me of the cable that we used in the Philippines with our 10,000 watt transmitters and 50,000 watt transmitters. And do you notice something about that? There's no center conductor, guys. It's also a pipe. Well, where's the RF? Well, the RF travels on the outside of the pipe, so you don't need to spend all that money on a solid piece of copper. And I'm sure you spent enough on that anyway. This is probably $30, $40, $50 a foot. Oh, really? 10? Is that all? Oh, yeah, okay. Foam or air is preferred, but they're susceptible to moisture. Guys, if you use foam dielectric outside, make sure you really, really wrap that connector well, and don't let people step on your cable. Watch for gnaws from squirrels. This, I can't say enough to you new hams. I have hams come over and they want me to put a couple of connectors on a 100-foot section. Okay, I can do that. How long's your run? Oh, I don't know, maybe 60 feet. Well, then make it 60 feet, cut it, and put on a connector. Only use the amount of cable you need, especially VHF, UHF. Okay? Very important. Coax can dry out, and if it's in a real damp warehouse, you can really have some problems. The company, the Fortune 500 company I worked for 17 years, we found 3 or 4 1,000-foot rolls of RG213. They'd been there 25 years. All the cable was ruined. The braid was green, and the dielectric had gone brown. And we threw them all in the dumpster.
Yes, sure is.
Okay, what do we got here in the state of Virginia? Yeah, sun, rain, snow, ice, wind, pollution. And if you don't believe we have acid rain, look at your car sometime if you don't put wax on it. We have that. All harmful to coax. Coax also should not wave in the wind. That also is not good on it. Replace your coax. Now, this is important, guys. Replace your coax. If you go outside and you end up with black on your hand, that means that your jacket is starting to go. It's starting to be UV'd. Number 2, cracks or punctures. What I always like to do is inspect it very carefully and look for cracks or punctures. Number 3, we didn't have squirrels in California. I don't know, out here we got squirrels and chipmunks. They love to gnaw and chew coax. And here's another thing that coax doesn't like. Guys, this is another thing that coax, there we go. Coax really doesn't like that at all, okay? Meaning running over it with a car. We had coax on the roof at my last company, and people would step on it on the roof, and we had a rocks roof, and those little rocks would come in and make holes, and then the water would wick in just like a sponge. Exactly. Oh yeah, this is no longer 50 ohms, John. This is what I do every year, guys. I actually unhook my antenna and put a bird watt meter outside with a dummy load, and then I go inside and put another bird watt meter, and I put 100 watts gazinta, and then I go outside and read the gazouta, and I calculate the dB loss of the cable, and that way I keep up on it. And do most of you in here speak dB? Does everybody speak dB in here? Most of us? My dB loss of this beautiful 9913 cable is 0.3 dB. I have 94 feet of it. 0.3 dB at 7 megs. Yeah, I am. And right there, I replace my amateur radio coax every 5 to 7 years. And I'm due. I'm on my 7th year right now, and I'm trying to talk Lee to going up in my attic because I got that insulation up to here. You guys know it's terrible up there. But I'm pretty much due. And I took a look at it yesterday. It still looks pretty good. Okay. Electrical and mechanical functions. These are critical, guys. Please roll it and unroll it the proper way. Yeah, like that. And I can never thank you enough for making those coax storing devices we have for field day, because this is normally how this is how we used to get it out in the field. It'd be mailed to us like that, see. So the proper way, and this is only a few feet, guys. This is hardly anything at all. But the main thing with coax is not to kink it. That's the main thing. So we like to take usually 10 inches to a foot, and then we wagon wheel. Okay, I usually tie it off with a cable tie, which I don't have tonight. But you want to keep and maintain the circle. Never do this. And when you take the cable off, see, I'm twisting it, making it nice. When you take cable off a reel, say a 100-foot reel, never do this. Each one of those poles is a kink. You always de-wagon wheel it. And we had a rule when I was with the agency that when you're on a roof, you do the two-step rule. 1, 2, look behind you. Didn't want you walking off the roof. A lot of paperwork. That's the proper way, and I think pretty much we got people doing that at field day now, you know? Oh, very good. Very good. Okay. All right. Oh, how about this one? Oh, I love this one. I used to have my students go to Bull Run Park. Nice wet morning, grass, and they'd pull the connector right through the grass, hook it up to the radio, and the Viswars is 63-1, right? Mr. Payne, we have a problem with the cable. I then have them take this off and go, and they get a mouthful of water. So guys, and keep it off concrete also. Don't drag it across concrete. Have a lot of respect for your connectors, please. Bend radius. What's the magic term for bend radius? Anybody know how you figure it? Take the diameter of the cable times 10. So let's take RG213, which is 0.405 inches, times 10. So about 4 inches. About 4 inches. Okay? Bend radius. That's how you figure bend radius. You don't want to go beyond that. You don't want to overdo bend radius, especially on this LMR double shielded stuff. If you go beyond the bend radius, I'll just do it because I have a lot of this. What we've done now is the center conductor is probably shorting or real close to that aluminum foil. Real close. So, all right. Oh, it's probably, well, I don't know what. It's pretty low. Let's see. Oh, yeah, and like I just said, please preserve the proper thickness of the dielectric. That's why I pounded on this. That's very important in coax cable, is maintaining that distance from the center out. Jacket integrity, okay? And I can't say it enough. Don't walk on it, don't drive on it. Be good to your cable. Okay, little show and tell for those of you who have not seen cable before. And I've labeled all these. Well, actually, I'm going to let you read it right off the cable. This is RG174, and we use this for very small jumpers. Use it on HF. I think what's funny is your 2-meter whip antenna that you buy, your mag mount, a lot of times comes with this. 10 feet of it. Do the math. So guys, this is RG174. Now we have a military RG174 called RG316. This is dielectric here is PVC or polyethylene. This is Teflon. The jacket here is PVC. This is Teflon. A lot of times the stuff that I've bought in the past, the RG174, the braid is not tinned. This is tinned, but this is always tinned. And 7 strands of number 30, 7 strands. And I'll pass these around for those of you who have never seen the little stuff. There we go. You can read it right on the cable. One is made by Belden there. Yo, John. Oh, yeah. I mean, the wire is tinned before they make the braid. No. And I mean it's tinned with tin. Okay. Now, RG58. My God, I got so many questions from everybody that I wrote a special slide just for you guys on RG58. This is a very common cable, 0.195 inches, which RG58 should I buy? Well, and this is great for HF, by the way. I use this, 50-foot run for HF. This is fine. This is fine. If you're only running 100 watts, it's good cable. You don't want to spend much. But here's the question I get. Hey, Ron, I've seen like 4 kinds of this. Well, there's RG58 standard with no letter. Bare copper, solid, and notice it is a contaminating jacket, so it's not UV'd. RG58A, I'll bet some of you in here have some RG58A. Here's the thing, 7-strand. I've even used it outside. Good grief, it's a contaminating type 1 jacket. No, you don't want that. RG58B is almost impossible to find. I have never even seen it for sale. Look what the center conductor is. Really? Copper-coated steel? No, I don't think we don't want to do that. We don't want to do that. So guys, the Ron Payne answer of the day is if you're going to buy RG58, buy the C. That's what this is. Tinned, 19 strands in the center conductor. Non-contaminating type 2. This is the stuff. And where do I buy it? The usual place, the RF connection. It's about 26 cents a foot, okay? Any questions on RG58? Because this is a big deal with us ham operators. I mean, I use this for the past 60 years. Of course, I never knew what I was using. Then I did some research. So it's the C you want to buy. Okay, we have a company called Times Microwave. Now, let's back up a little. How many in here are using RG8X? Aha. Kevin, the good stuff or the the Times Microwave stuff or the knockoff? Good for you. Guys, I've had a lot of you hams come over to my house with stuff that I'm not putting any of my connectors on. I mean, it's knockoff. The foam is terrible. The braid is about 85% instead of 96 like you want it. The dielectric is like terrible foam. I would like that. There is a lot of junk out there, guys. So if you're going to use RG8X, which they never had when I was a kid, I want you to go buy TMS. Who's that? That's Times Microwave. LMR. What's LMR? Land Mobile Radio. 240. Guess what the 240 is, guys? 240, 242. It's the outside diameter. And, of course, UF. Please make sure that you ask for UF, Ultra Flex. If you just get LMR 240, period, it'll have a solid center conductor, and you're going to be real upset with yourself because it's really hard to work with. You're not going to be doing this all day with it. Make sure, LMR 240 UF. Yes, it's a little expensive, but here's one thing I really like about Times Microwave. A born-on date, just like Bud Light. Look at this. May 8th, 2016, that cable was made. And I also think you're going to like the jacket. The jacket is a real nice PVC. And read on there, Ray. You can read on the cable. Yes, I do. I do. Yep. Okay. The next one, guys, is anybody in here using RG213? Oh, okay, we still got a few people using yeah, I know. Lee bought his in 47, I think. Guys, this is, anybody know what RG213 is? It is basically the replacement for RG8. And it is an RG8 type cable in that it is 0.405 inches. Nice solid PVC, Nice solid polyethylene dielectric. Please note that the braid is not tinned, it's copper. The solid, the center conductor, is 7 strands. Very nice to work with. Very nice cable. And I think I've used this for 50 years. I remember growing up using RG8, and then they came out with 213, and everybody says, hey, what's the difference between standard RG8, that you can still buy, by the way, and RG213? Well, it's got the Type 2 jacket, which means UV, petroleum resistant, that's good, and direct berry. I don't think anybody uses straight RG8 anymore. Is anybody using that in here anymore? See? Okay. Yo.
Ever heard of RG214?
Yes.
Yes.
Yes, double shielded. 213. Yep, nice stuff. Nice stuff. Need a special connector for that too, Bob. Yeah. Oh yeah, you just jam that. Take sandpaper. There we go. I'll cut off that. There we go. Okay, guys. Now we're at the Ferrari. This is Belden 9913F7. Notice it's an RG8 type. They don't have an RG number for this, so they didn't get listed in the radio guide. They probably didn't want to spend the money. And you don't think that Times Microwave was going to let Belden get away with having the product, so they came out with LMR 400 UF. It's almost the same thing, except the jackets is a little more shiny on the Times Microwave. So guys, here's another one. If you buy this, and this is my favorite, it's what I run all over the house, make sure you specify F7, flexible 7 strands. Flexible 7 strands. If you go out, and I had a student of mine came in with 100 feet, and he said, here, this stuff's really stiff. And I said, well, you bought 9913. That's what you said. I said, no, I said 9913 F7. 9913 has a solid center and an air dielectric. And you do this once, okay, you're done. So, notice it says Belden 9913 high flex, low loss, RG8 type, 50 ohm. RG8 type meaning it's 0.405 inches in diameter. Okay, guys, any questions on the Coax?
Harden it.
No, not really. It'll break. I just don't like it because it's so hard to work with. Yeah, Mike.
Several different kinds of LMR 400s. Are you going to talk about that?
No, just the ones that pretty much we use in here. And yes, there is a whole sheet of those. But if you get LMR 400 UF from the RF connection for your ham radio use, he'll know what you need. Yeah, there are.
The foam is not very good. At least that's what I've read.
Well, if you go to RF connection, he would rather sell you Belden. There has been some problems, he said, with certain runs. Anybody ever got bad coax at home? I mean, buy the good stuff. I bought 100 feet of RG58C, and the ferrules, the jacket was uneven, and the ferrule would stop. So it was built like this. What happened? Well, I just got a bad run. That's all. Got a bad run, turned it back in, and got a good run. Okay, guys, any questions on... Okay. That's forced high density polyethylene. Okay. Yo, John.
High frequency.
Losses? Oh. Oh, I'll tell you, bang for the buck on this. Well, I'm way overdoing it. 94 feet, John, 7 megahertz, 0.3 dB loss.
Excellent.
Oh, a little more. Maybe 1.5. But I have a chart. It's all charted out. All right, guys, talk about connectors. All right. Okay, a coax connector. Actually, the radio would rather have the cable soldered into it. That's the best way. A coax connector should be a homogeneous electrical extension of the cable. In other words, the connector isn't there. The RF just sees, whew, goes right in. Shouldn't even see the connector. How about that one? How about that one, guys? Hundreds or thousands of interconnect cycles. We really abuse things, yes. Yeah, like the SMA. And we'll get into that in a minute. Easy. We can crimp a connector. We can clamp a connector. We can compress it, or we can solder it. And today, private industry, we crimp unless we have to solder. It's got to have your high frequency characteristics. In other words, you're not going to use a PL259 at a gig. Okay? This is one thing that I had people ask me about. I've had students hook up a connector into an SO239 and said, geez, this is too tight. It's too tight. That's good. You don't want, again, knockoff connectors. There's a lot of junk out there, guys. You do not want a loose connector because what you get is micro arcing in the pin. And that micro arcing causes noise on receive and on transmit the same. So a good tight fitting connector, yeah, that's what you want. Okay, got to have good voltage rating on the connector. Finger tight or torque wrench. You SMA guys, we use torque wrenches, 8-inch pounds. 110. Okay. And we'll talk about SMAs in a minute. Yes, thank you. And guys, if you're going to put your cable outside, please seal it, and I'm going to show you how to do that today. Just one method I use. All right. 3 categories of connectors. You got threaded, bayonet, and push-on. Anybody using any push-on? I've got a PL259 push-on, but never use it. I think most of us in here will use bayonet or threaded. I do have SMBs. Anybody know SMB? Yeah, that's a push-on. That's a, there we go, push-on connector. Oh, I meant to say that coax cable is RG. All connectors start with UG, like a TypeIn. You want to buy a TypeIn? Well, my logistics would say, what's that? Oh, it's a UG76. Oh, yeah, we got those. Okay. So you got to have the right UG. It is the most important component of an RF system as far as I'm concerned. You can screw up your $50,000, $100,000 radios, and I've seen it done overseas. Guys, I flew TDY one time way down into Africa, and basically I went, okay, that's better now? Okay, that's good. Time to hit the pool. This is important, and this is what I'm going to be teaching in Mike's tomorrow, how to put them on properly. Guys, this is 2019. We crimp. We crimp with some real nice tools. This is $250 for the die and $120 for the body. And you need a lot of dies, Ray. You need $1,000 worth of dies. You really do. These are chrome lined. But guys, this, man, does this make a nice connection. And here's the thing, for those of you who aren't really into soldering, when you crimp, you didn't destroy any dielectric, did you? I know in the old days, putting on the PL259, get that solder gun, get that whole connector up to 700 degrees, dielectrics melting, end up with a 30 ohm connector. Yeah, there we go. Okay. Overheating can cause impedance bumps. Just what I said, you're melting the dielectric down to one side. And guys, you get what you pay for. I'm an Amphenol guy. Amphenol still makes great connectors. Amphenol Coax is the company now. There's a lot of junk out there. Buyer beware. Okay, for those of you who've maybe never seen a connector, we have nomenclature for you today. That's called the body. And now maybe a couple of new things for you. The barb. The braid goes over the barb. The ferrule goes over that. And then you crimp it. Okay? In our day, we soldered the braid. Male pins. Any connectors have female pins? Yeah, female connectors. And reverse polarity. There you go. Thank you. The little holes in the pin. I know everybody wants to call those solder holes. They are not solder holes. They're called inspection holes. However, can you solder if you want? Yeah, I do all the time. You can solder, put a nice little ball of solder, put some flux inside, flows in nicely. So remember, guys, you can solder a crimp connector pin, but you can't crimp a solder connector pin. Okay, plug assembly. All the gray-haired guys in the audience, remember the PL259? How many of those have we done in our life? Good God. The plug subassembly, we have the four, count them, 4 solder holes. And the cup, which in the military we cupped it over, made it nice and round. And then the one you always forgot to put on, the back shell. Remember that? You always forgot to put that on. You get a nice solder job and you forgot to put it on. I've done that numerous times. Boy. Okay. I bring this up. Knurling. All of these connectors here, the BNC, the PL, they have knurling. Knurling is for your fingers. Please do not put a pair of vice grips on knurling, because what happens, they'll slip, and the next guy that comes along puts his fingers on here and gets a handful of brass. Man, that's something else. I've had that happen. So knurling, hand tight, okay? All right, guys, we're just going to go over the big 4 here, and that's it. The PL259. Mr. Clark Quackenbush invented it in 1937, and it is the solder version. Let's see, there we go. PL stands for plug, and it mates with the SO239 on the back of all your radios. I don't care if you paid $10,000 for an HF radio, it's got that on it. Everybody says, what's 259? What? Well, it's probably the 259th try, the way I see it. I'm not sure. Why isn't an SO259 then? No, well, it's not. It was designed for RG8, the first coax cable. You can get adapters and reducers for other sizes. What I'm going to pass around here is the gold flash version, which I think is $2 instead of $1.50. And here's our dielectrics, World War II and the 50s and 60s. And now, guys, almost every connector that I have for you today to pass around Teflon. They found Teflon is just the best dielectric known to man. Pretty close to air. Good stuff. This is a PL259 silver Teflon gold. Yeah, I paid $1.50 for it. And here's the disadvantage of this connector. Non-constant impedance. They leak like a sieve if you don't wrap them. And those of us who have installed them, all you have to do is crimp one time and you will never solder one of these again in your life. Guys, what I'm going to do is strip this back, and I want you to see a perfect solder job for a PL259. I won't tell you who did it, Ray, but there you go. Use only up to 200 megahertz. Yet my 2-meter 440 rig has a SO239 on it. Go figure. All right. Those of you who want to know how to put them on, I have these. These are going to be online. And again, if you really want to, come on over. Come on over to the house. Put one on for you, show you how to do it. I have the crimp and the solder. Let me pass around the crimp. There we go, Ray. There's the crimp. Now, the first thing you're going to see when I pass around the crimp is that I have a little ball of solder here. So I crimp the pin, but what I do, I cap it with silver solder. I put a nice little hemisphere of silver solder, and it looks so pretty. It's all in how it looks. All right, the TypeIn. Here's the greatest connector ever made, right here. Greatest connector ever made. Paul Nile, 1943. Working at Bell Labs, invents a connector for radar because we were starting to get up, beyond 200 megahertz for radar. He comes up with his own connector. It's a wonderful connector. It's a double shielded connector. True 50 ohms, good up to 18 gigs. Insertion loss, it's not even there. A lot of guys I know don't even wrap it because they say, oh, there's a gasket inside. I don't wrap mine. I do. I wrap mine. But it is our good choice for HF or for VHF, UHF. You're talking anywhere from $8 to $12 for this, though. Okay? And what I'm going to pass around is a crimp. Now, guys, you see this? It says crimp here. See the inspection hole? The inspection hole means I got it up into the pin where I was supposed to. You want to solder that? Go ahead. Fine. We do it all the time. You want to crimp it? You can crimp it. It's 0.116. It'll crimp. All right, BNC. Now, I asked Bob a minute ago what BNC stood for. I think I've asked my students, and these are the answer I got from my engineering students. Oh, that's a bayonet nut coupling. No, Mr. Payne, that's a British naval connector. The British invented it. What? Mr. Paul Nile invented the N connector in 1943. Mr. Carl Conselman invented the C connector, which we used to use on the submarine for patch panels. Picture the C as a great big huge BN or a great big huge N that has a bayonet. They got together and formed the bayonet Nile Conselman connector, and it is right now the most popular connector in the world. But the stinking SMA is catching up. It's catching up. Yeah. So, TNCs, also have TNCs. 50 ohms. Nice small size. I liked it when they made our walkie-talkies with BNCs. Now all the Bofang and the Wausheng all have SMAs. Not cool. Insertion loss is small. Lower power handling capability. And I had an engineer tell me that the slots will radiate at 4 gigs. Like I care. So, now, guys, I want to show you something. What's that, Pete? No problem. I'm going to prove to you that they work together. I'm going to take a TypeIn male. And here's a BNC female. So if you're ever in a real bind, they fit perfect. They kind of pull out quick, but I pulled this trick working overseas with a group of people, and boy, they thought that was about the coolest thing they ever saw. So I was also told that you're probably not going to do that too many times because now you've widened the female pin on the BNC. But go ahead and try that. Oh, and here, Ray, there's the BNC male. Crimp, crimp. Any questions, guys? Again, I have all the cut charts and the crimp charts. I made all these on PowerPoint. These are all on PowerPoint and step by step, but it's still nice to be sitting in front of somebody and say, no, do this a little better. There's a couple little things that aren't on the chart here, but this is basically for the cuts. And here we go. Sure, mighty, aggravating. That's what this stands for. Bendix Scintilla in 1960 invented this to put from a waveguide to a PC board. You know, torque it down, leave it alone, and go away. What do we do in ham radio? We put it on and take it off, put it on, take it off, put it on, take it off. And I've even seen some people that I trained in the field use a crescent wrench. I've seen it cross-threaded. I've seen it stripped. And I had one guy I was training, and he put up his big military boot and sheared it right off the chassis. So this is sub-miniature version A. Yes, there's this SMB. You guys want to see an SMB? I'll pass that around too. SMB. Is there an SMC? Yeah. Is there an SMD? Yeah. SME, I'm not sure of.
Were to fix problems in the earlier ones?
No, just different sizes. Really, this is a push-on. This is, and by the way, Ross, I soldered that. I soldered the middle pin. That is a solder crimp. You need a solder iron with a pin tip. Good loss. Very popular for your Bao Feng and your Wo Xin walkie-talkies. They use these. And here's the problem with your walkie-talkies, guys. I know a lot of you have your Wo Xins out here today. They put a male connector on the radio. What? So what happens is every time you twist the antenna, which has a female, you're rubbing the male pin, and what you're going to do, one of these days, you won't have contact at all. You're just wearing it down every time. Yeah, it's just getting worse and worse. You know, these, when they came out originally, were only guaranteed for 25 mating cycles. 25. It's really doesn't belong on your radio, really. Can be damaged from excessive interconnect cycles, cross-threading, and over-tightening. There you go. Okay? Oh, do you? That's probably a good idea, John. By the way, I have the cut chart for that too. Notice, oh yes, notice one thing here, guys. 5/16 torque wrench. 5/16, 8 inch-pounds. Okay, we're done. Okay. See? Thank you, Kevin. Yes, I'm passing that around to show you guys how little 8 inch-pounds is. Now, I work for a satellite company in Fairfax. We launched 2 years back. The satellite that went up had 83 of my cables on board, and just before they launched, they went through and tightened all 83 times 2, 166 SMAs, and they torqued them all before launch, and the bird's up there today working. It works great. Okay, there's your installation procedure for that. Come on over. We can do it. Look at this, 7/16, 1/8, 3/16. I put all this in inches. All right, new subject, adapters. Do you all use adapters? We've become We've become crazy with adapters. Now, in my day, when I was a traveling tech, I carried this plastic box that weighed like 18 pounds, just full of adapters. And then this company came out with these wonderful little box of adapters here. And you got one of these? Okay, how many are missing? Oh, okay, that's good. Because you come over to my classroom and every single one's got one or two missing. I don't know where they are. Now, speaking of adapters, Ray, I got the perfect one for you. This is a TypeIn male on a garden hose. Okay, there we go. And it has not been tested yet. George is going to test it for me. I'm sure he'll come up with something there. Guys, the thing about adapters is an insidious station necessity. Expedient interface. Really, you shouldn't really leave them in the circuit all the time. And for God's sake, don't put them outside. They have terrible weatherproofing characteristics, non-constant impedance. Just another point of failure, and there you are. Now again, that's just me talking, but I wouldn't think of putting one outside. Have I ever seen this before? A guy wants to put together two cables. So he takes a double N female, puts that right there. Takes an N male and a BNC female, puts that right there. Takes a BNC male and SMA female, puts that right there. Okay, Ray, I think you're an adapter junkie then. Well, that's another fallacy. You actually have to put it on a TDMA to C. You got to put it on a time domain. I've seen everything from 6, 7 dB, but the 3 dB rule, no, it's not really. That's a fallacy. But just don't stack them. Now, what you can do, though, Mike, is keep it in the family. Type in, type in, type in. That's okay. Doesn't even see it. Doesn't even see it. Okay? That's fine. It's when you start mixing families. Okay, last subject, guys. Waterproofing and splicing. Scott 33, remember that? We used to all use Scott 33 up until about 20 years ago. It's UV. Good stuff. When you take it off after a few years, sticky, gets all over your pants. We got Scott 35. I've used that inside of humid attics, let's say. Extreme was, I used to buy that at a marine store in Woodbridge. This is self-amalgamating silicon, which is about 15 bucks a roll. I carry a roll of this in my glove compartment so I can repair my radiator hose if it goes. Coax seal, oh my God, remember this? Anybody use this stuff? Coax seal? We called it, in the Navy, we used to call it monkey excrement. Yeah. And you guys, it never gets hard. It just stays yucky. It does, and I know it'll last in a rainforest, but nah. Okay, so here, what do you want to use? Coax wrap. And guys, this is the greatest stuff known to man right here. Coaxwrap.com. I get it from Amazon. It is self-amalgamating. Remember, you can't vulcanize silicon. It's self-amalgamating silicon. You wrap it, and 30 minutes later, it's a solid piece of silicon. And what I'll do it for you here in a minute. So, I'm just going to show you what I do. I know I've given this speech at other ham clubs, and I get, well, that's not the way I've been doing it for 30 years. Okay, well, this is my way, okay? Jeez. So, guys, let's just say, yeah, electrician tape. Let's just say that we need to put these two cables together. Let's see, do I have a slide on that? Yeah, okay, there we go. I got two pieces of cable here and I need to put them together. And this happened to me in Somalia in 1993. One of the trucks ran over our coax. We buried it 6 inches down. It wasn't deep enough. It crushed the coax. So I got two pieces of cable I got to put together. So here we go with tank truck. How are we going to do this? I'm going to take a TypeIn male, put it on one end, take a TypeIn male, put it on the other, and in the middle I'm going to put a double female and hand tighten them. Now I know what you're thinking. You're thinking, why didn't he use a male and a female? It's in Mogadishu. I didn't have one. That's a very uncommon connector to have in your toolbox, is an inline TypeIn female. You just don't have it. But I had a bunch of males and I had a bunch of these. So I'm going to torque it down. And I know it only rains like once a year in Mogadishu, but here's what we're going to do, guys. Here's what we're going to do. I'm going to show you what I do. Put that there, get some scissors. And I'm going to take and wrap, and I'm stretching the heck out of this. Stretch, stretch. Did you notice the heat shrink? I didn't mention, thou shalt not put on a connector without heat shrink. Okay, I started at the middle. I went all the way past the shrink, and now I'm going to start back, and I am overlapping 50%. And I'm just stretching this. And guess where I'm going? Yeah, I'm going on the other side now. Do not let these touch each other, or it'll be a bad day. Now you realize I'm doing the cable this way. In real life, Ross would be holding one end, you'd be holding the other, and I'd be going like this, okay? But I'm making this real easy for the classroom here. Okay, I went all the way back that end. And now I'm going to go right back to the middle and stop, but there's a trick. There's a trick involved at the middle. Okay. Okay, when you get to the middle, I'm going to make a V. And I'm going to take that V and pull it and smooth it. I'll tell you what, you can bury that in Lake Michigan and be just fine. Now, in a half hour or so, we could take a razor blade. What's nice to strip this down, you just take a razor blade, right on the top, it peels like a banana, and there's no sticky, yucky stuff to get all over you. Yo.
Put together there two males into a barrel connector?
Yes, two male ends into a barrel end. Yes, very good. All right, guys. First off, any questions on anything I've done so far? Last slide. Here we go. You can use this if you want. DBs cost DBs, okay? I want you guys to buy, you know, you all spend a lot of money on your radios. Don't buy junk coax, and don't buy knockoff connectors.
These distributors.
I've seen it all. Ray, I have seen it all. You know, Ross brings up an interesting subject. I bought some RG6 quad shield just lately for TV use. And darn if the quad braid isn't stainless steel now instead of copper. And you just showed me some coax you had that was magnetic.
Pretty sure it was a copper-coated steel shielding.
Probably.
The parts got...
So guys, if we have time, Okay, I can end it here. What I was just going to do is put on a TypeIn connector, crimp, and just show you. Okay, 9 o'clock it is. Come over to the house, guys. Anybody? Come over to the house. I'll give you a demo. I think half of you have been over to my house anyway. And I'll build anything you want, any kind of cable, or show you how to do it. So There we go.
Bravo.
Thank you. Thank you, Ray. Thank you.